I know we're doing a lot today. Is this too much, or is it all kind of making sense more or less?
No, this is good.
All right, cool. You'll definitely feel, I think, ahead of the game when you guys get to it, which will not be long from now. All right, let's take a look at that unit circle again, and I'm just gonna draw this here. Okay, so that's more or less what it is. Now, when we think about these radian changes, that's also going to take place on the unit circles. So, for example, if we're talking about something simple and small, like a 40, like let's say even like a 90-degree angle, what would that be in radians?
Okay, 90-degree angle radians.
The fastest way is going to be to multiply it by pi over 180. That's just the fastest way, right? Where we have, if we start off with degrees on the top, then we'll just multiply by that ratio with degrees on the bottom. It's just going to, make it a lot faster. So we can cross cancel here, can't we, with 90 and 180?
Yeah, it becomes 1 and 2.
1 and 2. And so we get a final answer of?
I guess pi over 2.
Yeah, pi over 2. So if we have a 90-degree angle, and I'll draw the lower leg here on the x-axis, and the upper one here, that the location up here could be thought of as 90 degrees, which I'll write down, but it could also be considered pi over 2 radians. All right. Let's get some of these other angles here. Another very popular one, as we keep talking about, is a 45-degree angle. Well, we're going to convert that to radians by multiplying it by what?
Pi over 180.
Pi over 180. They cross cancel. The 45 becomes a 1. The 180 becomes?
It becomes 4.
It becomes a 4. So 45 degrees is equal to pi over 4, which also kind of makes sense. If pi is 180 degrees, we have 4 45-degree angles in that 180. So each one of those fourths, right, is going to get us, I'll just put this here, pi over 4. Great. Let's do the same thing with a 30-degree angle. Multiplying 30 by what?
Pi over 180.
Pi over 180. That's equal to, if we reduce or cross cancel, we know that 30 is equal to 1. The 180 is equal to?
6.
6. So 30 degrees is, the 30 degrees is the equivalent to pi over 6. So I'll just go ahead and draw that right here. And we'll say that that is pi over 6 radians. And finally, let's do a 60-degree angle. Multiplying 60 by what again?
Pi over 180.
By pi over 180. 6 reduces to 1. 180 reduces to
3.
3. And our final answer for a 60-degree angle in radians would be?
Pi over 3.
Pi over 3. Great. Okay. So those are the key ones that we really need to memorize here. Okay. So that means that if I were to say something like 135 degrees, for example, is equivalent to how many radians? Well, we know we could multiply it by pi over 180. But we could also see that 135 degrees is equal to 90 degrees plus 45 degrees, right? And 90 degrees is what in radians?
Pi over 2.
Let's move this here. Sorry. Yeah, it's equal to pi over 2. 45 degrees is equal to what in radians?
Pi over 4.
Pi over 4. If we get the same common denominators, pi over 4 would stay the same, but the other fraction would become what?
It would become 2 pi.
2 pi over 4. And so altogether we know that 135 degrees is equal to 3 pi over 4. Right?
Yeah.
All right, cool. Cool. Let's talk about what a reference angle is. I'm going to write this down here. A reference angle. All right. A reference angle is the following. It's today what we've been going over again and again are these angles in the first quadrant, right? 30 degrees, 60 degrees, 45, etc., even 90 degrees, right? Once you pass 90 degrees, we get into what are called reference angles. And here's what I mean. So if I have the XY grid here, and I have an angle that starts off as usual on the x-axis here, but the other side goes, let's say, to over here and creates a 150 degree angle. How can we get how can we get like the sine, for example? Yes, let's do the sine first. How can we get the sine of 150 degrees? Today we've gotten the sine of 30 degrees, the sine of 60 degrees. We made that whole chart up, right? How would we get the sine of 150? Well, here's how we would do it. We would actually use what's called the reference angle. And the reference angle is completely configured based on the x-axis and what degree measurement we get by going from the x-axis to the finishing line of our angle. So if this right here, right here is the x-axis, right? So the reference angle would be from that line to this one.
Okay.
How many degrees is that?
If we're going straight up.
Yeah, we're going in. So right now
90.
we're going from the other side. 90? Wouldn't you agree that this whole thing right here is 180 degrees?
Yeah, I would agree with that.
Right? So but this is what we're talking about. From 180, if this is 180 degrees, we want to know the degree measurement of this angle right here.
Oh, okay.
Right? From the x-axis up to that line.
Okay, yeah.
What is that?
I mean, am I supposed to know? Because it doesn't seem like I can get it, like...
Well, we would agree that this is 180 degrees, right? Going all the way across the x-axis.
Yeah.
And then we're talking about how many degrees in the angle that I started this problem with? 150, right?
30.
30 degree angle. There we go. All right. So the sine of 150 is going to basically be, and we'll talk about some small adjustments we might have to make, but it's basically going to be the same thing then as the sine of 30 degrees.
Okay.
So how do we now get the sine of 30 degrees? Well, we can either plug it into our calculator, look at the chart, or we can what?
I don't know.
We can use the unit circle.
Yeah, okay.
All right. So this is the first quadrant of the unit circle. Here's a 30-degree angle here. We'll just kind of go down from here, right? We know this is 60, this is 90. We know this is 1.
1.
I'll put that in blue. We know that's 1. So what are the other two sides, really quickly? We'll call this, yeah, you mean letters? Yeah, so A, B, and C. Yeah, go ahead.
Yeah, AB is 1/2.
1/2.
BC is radical 3/2.
Good. And then to get the sine.
To get the sine, okay, so since sine is opposite over hypotenuse, it would be 1/2 over 1, which would be 1/2.
Great. So the sine of 30 degrees is 1/2, right? So all we have to do is make sure there's only one last thing we have to do. Because sine of 30, however close it is in the way that we solve it to getting the sine of 150, there's one small little adjustment we may have to change. Not always, but we always have to examine it. And it's based on the following. If we have, and I'll do it in this color here. Here's our XY grid. All right. There is a little sentence we need to memorize here to help us out with this, okay? And the sentence is, all students take calculus. All students take calculus. A little mnemonic, where the A is the letter we want to put into the first quadrant. Where's the first quadrant? Upper left, bottom right. Where is it?
It's upper left.
Upper right. Upper right.
Sorry, I meant to say.
Okay. Good. Where's the second quadrant?
Upper left.
Upper left. That's where we're going to put what letter, do you think?
S.
S. In the third quadrant, we're going to put
T.
T. And in the fourth quadrant?
C.
Any idea what these four letters could stand for? Particularly the S, the T, and the C. Any ideas?
Sine, cosine, tangent.
Yeah. And A, any idea what that might stand for? It literally stands for the word that we use, actually. This word right here. All. It stands for all. Right?
Okay.
So we've got all, sine, tangent, and cosine. And what these all are telling you is which of the trigonometric functions are positive in which quadrants. Let me just unload that really quickly. It's very simple, meaning that in the first quadrant, all of the trigonometric functions, that is sine, cosine, and tangent, they are all positive. In the second quadrant, only sine is positive. If you end up looking for cosine or tangent in the second quadrant, they will be negative, and you'll have to write down that it's a negative answer.
Okay.
Tangent is going to be positive in the third quadrant. If you end up looking for sine or cosine in the third quadrant, those will be negative. And the same thing then for cosine in the fourth quadrant. Making sense?
Yeah.
So, if we go back to the problem we're talking about, where we're looking for the sine, not of 30 degrees, but the sine of what?
The sine of 150.
Is 150, well, which quadrant is 150 degrees in? We're talking again about the finishing line, right? Not the, right, just the line where it ends, where the degree ends.
Okay. Yeah, it's in sine.
It ends in the second quadrant. Is sine positive or negative in the second quadrant based on all students take calculus?
It's
What is sine in the second quadrant according to this cool little drawing we created here?
What was this drawing supposed to tell us if it's negative or positive? I don't see.
Yeah, all of these are telling you what is positive where. In other words, in the first quadrant, all of them are positive. In the second quadrant, only sine is positive.
Okay.
Now, you just told me we're looking at the second quadrant, right?
Yeah, so
Is sine positive or negative in the second quadrant based on all students take calculus?
it's positive.
Great. So our final answer, we'll take the sine of 30, which is 1/2, and we'll leave it as a positive answer because sine is positive there. And that's our final answer there.
Okay.
Making sense?
Yeah.
All right, cool. Let's do one more of those. So, and don't forget, all students take calculus. I'll just leave it right there, I guess. So let's say we're now going to get, the cosine of 240 degrees. The cosine of 240 degrees. How are we going to get the answer to this?
Okay. The cosine of 240.
First of all, we're going to draw it. All right. We'll go through it together because I know this is a lot of new stuff, right? First thing we're going to do is we're just going to draw the basic angle. So the angle, of course, is going to start over here. It's going to pivot around the center right there. And it's going to go to where? Well, we know that if it continued to here, right here, that would be 180 degrees, right?
Yeah.
But it's going to go further than that, isn't it? How much further than 180 degrees is it going to go?
Pretty far. I mean,
Well, how many degrees further?
240 degrees further.
It's going 240 degrees from where it starts, but it's going to go how much further than 180 to get to 240?
Oh, yeah, it's gonna go 60.
60 further. So I'm just going to draw that. Approximately 60 degrees further. Do you see what I'm saying?
Yeah.
All right. So we know that this whole thing here, mark it here. We know that this whole thing here is 240 degrees, right?
Yeah.
But it's only going 60 degrees further than the x-axis, and that's what's really important. I'm going to mark that right here. From here to here is only 60 degrees. Why is that so important? Because that is our what? What's it called?
It's our tangent.
It's called our reference angle.
Oh, yeah. Okay.
Right? The reference angle is what helps us solve these problems. When you and I figured out that chart a long time ago, getting the sine of 30, etc., we only got these small little angles. Sine of 30, sine of 45, sine of 60. We didn't get the sine or the cosine of 240 degrees, right? So in order to solve for these larger angles, we actually need to use the reference angles. Is that making sense?
Yeah.
Okay, cool. So now instead of getting the cosine of 240, we'll come back to that in a minute. We're actually going to get the cosine of what?
But cosine of the cosine of 30, right?
Why 30? Tell me why 30.
Because
We're interested in the angle between the finishing line and the x-axis. This angle right here.
oh, okay.
Right? It's always the x-axis and that finishing line, which we both agreed is not 30, but how many degrees?
60.
And what kind of angle is that called again?
Reference angle.
That's our reference angle. That's what we're looking for. So we're going to get the cosine not of 30 degrees, but of
60.
60 degrees. Great. How do we get that?
Oh, we had it. It was like pi over.
Should we just quickly do the
Yeah, sure.
Okay, we'll do that in this color here. So we've got this and we've got this. And we're going to create a 60-degree angle this time, right?
Yeah.
So I'm going to draw from here up to about here. Here's our, oopsie, let's use this. Here's our unit circle, just the positive quadrant. And we've got our 60-degree angle here. So here's 60, here's 30. We know that that this is equal to 1. What are the other two sides equal to?
1/2 and radical 3 over 2.
Good. So the bottom one is going to be 1/2. This one is going to be radical 3 over 2. Great. Let's get the cosine based on standing in a triangular room in the 60-degree corner.
Okay, yeah. So cosine is,
Adjacent over hypotenuse.
which would be 1/2 over 1.
Over 1.
Be 1/2.
Great. So the cosine of 60 degrees is just equal to, we'll just put it over here, 1/2. Is then our final answer going to be equal to 1/2? Is the cosine of 240 exactly the same as the cosine of 60?
Yeah.
All right, so I'm going to write that down, that we like 1/2, right? Not bad, but there's one last thing we need to look at. What is it?
If it's
we have to look at our all students take calculus, right? What quadrant are we in when we look right here?
we're in the tangent. We're in the take.
We're in the tangent quadrant. We're in the third quadrant, where only what is positive?
Only tangent.
Right. So since we are looking for cosine instead of tangent, are we going to have a positive or a negative answer?
Negative.
Right. So our final answer then is going to be negative 1/2 instead of positive.
Cool.
Making sense?
Yeah.
Right on. Right on. A lot of good stuff today, man. We covered a lot of math. Whoa.
Yeah.
Good stuff. Is it all kind of making sense, or more or less?
Yeah, definitely. The first half, I mean, like, the majority of the lesson was pretty good.
But if I were to if I were to give you a rating on the other half, I mean, Adam, like, don't quit your day job.